Now that I've oriented you to what calculus is, let's talk about some applications of calculus, particularly with respect to machine learning. Differential calculus, so finding the slope of curves, is particularly used today to optimize by finding the minimum or the maximum of a given curve. So it's used, for example, in engineering to identify situations where we have maximum strength, as well as in, say, finance, to identify situations that minimize cost, that minimize expenditure. And differentials are widely used in machine learning, including its deep learning branch. Specifically, we use a technique called gradient descent to minimize cost. So we have a cost curve here where we can adjust, we can use machine learning to adjust a model's parameter in order to minimize cost. And by minimizing cost, we then get as close as possible to the correct output for our machine learning algorithm. And so we want to identify the location where cost is minimal, and that point is going to be a point where slope is equal to 0, where we're at the bottom of this cost curve and the line stops going down and starts going up. So, we'll start at any given parameter value in machine learning, and then we want to gradually adjust that parameter value. So that in this case, adjust the parameter value down, and we'll gradually make our way to this point where slope is equal to 0. It's the minimum of this cost curve. We're going to talk a lot later on in these live lessons about gradient descent, and we are going to detail the specific calculus that's required to accomplish gradient descent. As a quick example, we'll head now to johncrone.com/deeptf1 to see a deep learning algorithm and gradient descent over time in there. So heading to johncrone.com/deeptf1 with a capital T and a capital F, that brings us to this Jupyter Notebook of a deep neural network in TensorFlow. And the specifics of this don't matter too much at this time. I just want to show you an example of how we have a certain cost. I'm showing 20 rounds, 20 epochs of training here. And you can see that at the beginning of training, cost is high, and the accuracy of our machine learning algorithm on this task, which is identifying handwritten digits correctly, it is not super accurate at the beginning of training. It's 83% accurate. But over time, using calculus, differential calculus in that gradient descent algorithm, we are able to adjust our cost downward until our model is 99% accurate on the training data. And then as an example of finding a maximum of a curve, in machine learning, we actually use the same algorithm as gradient descent, but we use it, instead of using it to minimize cost, we use it to maximize reward. So find the point of the curve like a peak of a mountain as opposed to the bottom of a valley. And I have this notebook here at johncrone.com/all capitals DQN that shows an example of that. So heading to that URL now, it'll bring us through to this Jupyter Notebook called Cartpole DQN. And in here, our objective is to create something called a deep reinforcement learning algorithm that learns how to play a simple game. And the objective of the game is to keep a pole balanced on top of a cart for as long as possible. And the maximum score in the game is 200 points. So that's our maximum reward. And so we're trying to maximize and get to that 200 mark. And so at the beginning, before our machine learning algorithm has done much training, the score is relatively low. We're getting nowhere near 200. But over time, using differential calculus to ascend the gradient and maximize this reward, we're able to gradually make our way to consistently hitting this 200-point score. Noting, however, that we're zero indexing, so a 199 is equivalent to 200 in a one-index system. There you have it. Those are rough examples of using gradient descent to minimize cost or gradient ascent to maximize reward. So examples of differential calculus being used in machine learning, including deep learning. And we're going to dig really deeply into gradient descent in these calculus live lessons. We covered earlier in these live lessons this idea of higher order derivatives, where we are able to go from not only the first derivative of distance to speed, but then again to the second derivative from speed to acceleration. And so these kinds of higher order derivatives are used in fancy optimizers. Nobody calls them fancy optimizers but me. But so they kind of build on this gradient descent idea to enable finding this minimum of the cost curve even more quickly by taking into account acceleration along this curve. And we talk about that in detail in my 8th and final subject of this Machine Learning Foundation series, and that's on optimization. All right, so that gives you a sense of modern differential calculus applications, particularly to machine learning. Well, what about integral calculus, that other branch of calculus? So remember, with integrals, we can find the area under a curve. And so here's an example here where we have this orange line representing a curve, and we can find the area under that curve. Well, this specific example is something called the receiver operating characteristic curve, and it is commonly used to quantify the performance of a machine learning algorithm that is classifying something into some input into two different categories. And we're going to talk about that near the end of these live lessons in the Calculus 2 subject. And we also see integrals as another modern example related to machine learning. We also see this in probability theory, in the expectation of a random variable. And so this is a widely used concept in machine learning, including deep learning, and we will talk about that not in these calculus live lessons, but if you follow along to later lessons in my Machine Learning Foundation series, we'll talk about that in the probability and information theory subject. Right, if you're wondering about this Machine Learning Foundation series that I've mentioned a few times now, you might have seen in the GitHub repository when we talked about those 8 subjects. I talked about 8 different notebooks being available to you. And so let's talk about those now here and give you a sense of perspective. So this Calculus 1 subject that we're tackling right now, focused on differential calculus, it builds upon the Intro to Linear Algebra and Linear Algebra 2 subjects that I cover in a Linear Algebra live lessons. And so in those subjects, we talk a lot about particular libraries like NumPy, PyTorch, and TensorFlow, which we will use again in this calculus course. And we also get you used to thinking about objects as tensors, scalar tensors, vector tensors, and that kind of terminology will come up in this calculus class as well. So right now we're in Calculus 1, and we're going to be talking a lot about limits and derivatives in particular. Limits are coming up next, and then we'll get into derivatives, which the theory of derivatives is derived from limits, so limits will form a good foundation for that. And then later on in these live lessons, we'll get into Calculus 2, as I've mentioned it a couple of times, and in that we focus on something called partial derivatives, and we'll also talk about the integrals, which I've now introduced to you a number of times. All of these calculus topics will themselves be foundational for the later subjects in the series. So probability and information theory, I mentioned this on the last slide with respect to integral calculus. There's also an intro to statistics class, and then we'll get into computer science subjects, algorithms and data structures, where again, understanding calculus will come in handy. And then we'll tie everything together with this optimization class. I talked about the fancy optimizers already, and so this 8th and final subject will tie together all of the preceding 7 subjects. And by the time we get there, so starting with Calculus 1 now, we'll start to dig into how gradient descent works, and over the course of the remaining subjects, we'll fill in more and more pieces of the puzzle until by this final class, you have a really deep, intimate understanding of gradient descent, as well as other topics in machine learning. And I've used bold here to represent that this Calculus 1 subject that we're tackling right now is especially important. So it's foundational for all of the later subjects in this series, but it's especially important, of course, for Calculus 2. And it's also especially important to being able to grasp the optimization class coming at the end. Nice, so that gives you a tour of what you can expect from studying calculus specifically, as well as the foundational subjects of machine learning in general. Up next, we're going to talk about limits, one of the major components of this Calculus 1 subject.